Welcome to the new discussions on exponential and logarithmic functions, which is inverse and composite functions. In grades 8 and 9, we said that a function f can be thought of as a machine that receives an input, let's say x, from the domain, manipulates it, and outputs the value f of x. The function f receives x as input, manipulates it, and outputs it as y. The inverse of f would undo what f does and receive y as input and provide f as output. So, if a function takes inputs and multiply it by a certain number, then the inverse would take inputs and divide it by the same number. For the inverse of a function, f must be one-to-one function. Inverse function is usually denoted by putting exponent -1 after the function letter like this: f raised to -1 of x, which is read as the inverse of f of x. Warning class, f raised to -1 is a symbol for inverse function of f. Let me remind you that -1 here is not used as exponent. That is, f -1 doesn't mean the reciprocal of f. F raised to -1 of x is not equal to 1 over f of x. Let's start with this first example. The function f of x 2x plus 1 all over x minus 1, where x is not equal to 1, is 1-to-1. Find its inverse. So the first thing you have to do in finding class the inverse of this is you have to change f of x to y, to its original variable, which is y. So this will be y equals 2x plus 1 all over x minus 1. The first step in identifying inverse function is to change x to y, y to x. So we need to say class, yung x magiging y, yung y magiging x. So with this given, this will be x is equal to 2y plus 1 all over y minus 1. So you see, yung y naging x, yung x naging y. After changing x to y, y to x, you have to solve now the equation in terms of y. So with this, we have to cross multiply this. Okay, this will be x times the quantity of y minus 1 equals to y plus 1. So, by distributive property, this will be xy minus x equals 2y plus 1. Since we are resolving this in terms of y, we have to isolate all terms with y. So you have to transpose 2y to the left side, then negative x to the right side. So having this, it will be xy minus 2y equals, from negative x, it will be now positive x plus 1, since you also transpose negative x to the other side. With this, we have to factor y to xy minus 2y for us to solve this in terms of y. So this will be, factoring this, y times the quantity of x minus 2 equals x plus 1. Divide both sides by x minus 2. Since we're solving for y, we have to remove terms that is beside y. So divide both sides by x minus 2. So having this, your answer now is y equals x plus 1 all over x minus 2. Since we already solved for y, we have to change now this y, the variable y, the inverse symbol, which is f -1 of x is equal to x plus 1 all over x minus 2. So this is now the inverse of the given function. Let's have another. Find the inverse function of g of x equals 2x plus 1 and check. So this time, we have now condition that we have to check if our answer is correct. Later on, you will know what's the rule in identifying if your answer is correct. So let's do the same thing. Change the g of x into its original variable, which is y. So this will be y equals 2x plus 1. First step again is to change x to y to x. With this, it will be x equals to y plus 1. Since we're solving for y and we only have one term here with y, we have to transpose positive 1 to the left side since y can be now isolated. So this will be x minus 1 equals to y. Then cancel 2 or divide both sides by 2 to cancel the coefficient in y. So this will be y equals x minus 1 all over 2. Since we solve now for y, change now y again to to the inverse symbol. It will be now f raised to negative 1 of x equals x minus 1 all over 2. So how do we know now if this one is correct? We have to check. You have to make use of the original given, which is 2x plus 1. Now, in checking, you have to replace here your x with your answer in f of x, which is x negative 1, x minus 1 all over 2. With this, it will be 2 times the quantity of x minus 1 all over 2 plus 1. Since we can cancel the 2, this will be now x minus 1 plus 1. Since you can combine negative 1 to positive 1, it will be 0, leaving only x. Now, you will know your answer is correct if you check this and the final answer is x. That's the rule in identifying if your inverse is correct. Composite functions. A composite function is a function that depends on another function. A function is created when one function is substituted into another function. For example, f of g of x is the composite function that is formed when g of x is substituted for x in f of x. F of g of x is read as f of g of x, and we denote open dot as the symbol class for composite function is an open dot, just like this. Let's start with this example. Given f of x, which is 2x minus 3, and g of x equals 3x plus 4, find f of g of x and g of f of x. To solve this, we should get the equivalent composite function of the given. So this will be f of g of x. Now the first thing you have to do is you have to change the inner function with its given. So since the inner function here is g of x, we have to replace this with the given 3x plus 4. So this will be f of 3x plus 4. Now this is where composite function takes place. The outer function here is f. So we have to replace now the x in f of x with 3x plus 4. Now your x here, now your f of x here is 2x minus 3, meaning to say class, you have to replace now the x in f of x with 3x plus 4. So this will be 2 times the quantity of 3x plus 4 minus 3. Then solve this by using distributive property. This will be 6x plus 8 minus 3. Combine similar terms. We have here 6x plus 5 as our final answer. Let's have the second problem. Find g of f of x. You know, in this case, your inner function here is 2x minus 3. And your outer here is g of x. Given g of x, which is 3x plus 4, you have to replace now the x here with 2x minus 3. So this will be 3 times the quantity of 2x minus 3 plus 4. Applying the distributive property, this will be 6x minus 9 plus 4. Combine similar terms, your final answer now is 6x minus 5. Let's have another. Given f of x equals x squared minus 3 and g of x equals x plus 2, find the following. G of x, then f of x. So let's start with the first problem. G of f of x here, the inner function is f of x, which happens to be x squared minus 3. So with this, your outer function is x plus 2. So replacing the x with x squared minus 3, this will be x squared minus 3 plus 2. Combine similar terms, then your final answer now is x squared minus 1. Then, second problem is f of x. The inner function is x squared minus 3. Now, your outer function here is also f of x, which happens to be x squared minus 3. So do the same thing. Replace now the x here with the inner function, which is x squared minus 3. So having this, it will be x squared minus 3, the quantity squared, minus 3. So, squaring binomial, this will be x to the fourth minus 6x plus 9 minus 3. We all know that we can only combine here the 9 and negative 3. So your final answer now is x to the fourth minus 6x plus 6. Let's have this another example. Given f of x, 2x minus 5, g of x equals 3x plus 2, then h of x equals x squared. Find f of g of h of negative 1. I have presented two methods are explained in your module. Please refer to the given module. Now, the method that I will explain for this video discussion would be finding first the f of g of h of x of this. You have to solve first for f of g of h of x. So with this, the equivalent composite function of this is f of g of h of x. Notice that your most inner function here is h of x. So replace this now with the given h of x, which happens to be x squared. You have here now f of g of x squared. So before you solve for the outer function, you have to check first if there are no more functions inside of the function. So we have to solve first for g of x squared. Your g of x here is 3x plus 2. So which means replace the x with x squared. This will be now 3x squared plus 2. This is now your g of x squared. You can solve now the outer function, which is 2x minus 5, which is f of x. Okay, so with this, replace now the x with 3x squared plus 2 of f of x. This will be 2 times the quantity of 3x squared plus 2 minus 5. So applying distributive property, this will be 6x squared plus 4 minus 5. Combine for the negative 5, it will be 6x squared minus 1. Now that we have f of g of h of x, we can now solve the f of g of h of negative 1 by replacing the x in our answer with negative 1. So having this, it will be 6x squared minus 1. Substitute negative 1 to x. This will be 6 times the quantity of negative 1 squared minus 1. Negative 1 squared is 1. So 6 times 1 minus 1 would be 5. So this is now the answer in this problem.